Hello students, and you are welcome back to solve your physics past question class. Today we look at the concept of capacitor in today's class as we solve our question from West African Examination Council from the year 2000 to 2010. As we solve our question, we solve questions around capacitor and everything that we have to do with capacitor in series and in parallel, looking at the concept of energy, finding voltage, and as many questions we might come across. The first question I have here with me is from the WAEC past question 2005. Calculate the charge stored on a 6 microfarad capacitor when it is connected to a 15-volt battery. So how do we calculate the charge? We all know that the formula for the quantity of charge in a capacitor is equals to capacitance times voltage. So from our question, we're given a capacitor to be 6 microfarad and we're given a voltage of 15 volts. So we can convert our 6 microfarads to be 6 times 10 raised to the power minus 6 farads. So by plugging this into our formula, so we have quantity of charge equals to 6 times 10 raised to the power minus 6 times 15 volts. So by multiplying these together, we then have 90 times 10 raised to the power minus 6 coulombs. So we have 90 microfarad coulombs. The second question we have here today is from the WAEC past question 2006. It says 3 capacitors, 2 microfarad, 3 microfarad, and 6 microfarad are connected in parallel. Find the total capacitance of the combination. When you see a question like this that we are told that 3 capacitors were connected in parallel, so we'll be using the formula. The total capacitance is equals to the first capacitance plus the second capacitance plus the third capacitance. Just as I have informed you in our previous classes on capacitor, that capacitor is just like the opposite of resistance. The formula to calculate resistance in series is the same formula you use to calculate capacitor in parallel, while the formula you use to calculate capacitor in series is the same formula you use to calculate resistance in parallel. The two are like that. They are opposite each other. So when you have this understanding, it makes you to solve your questions easily. So we'll be using total capacitance of our parallel to be C1 plus C2 plus C3, just as we're given in our questions. So we're given the first capacitor to be 2 microfarad, the second capacitor to be 3 microfarad, and the third capacitor to be 6 microfarad. So let's plug in these to our formula. So we have total capacitance equals to 2 microfarad plus 3 microfarad plus 6 microfarad. So that makes 11 microfarad as our final answer. And the next question we'll be looking into is from the WAEC past question 2007. It says a 10 microfarad capacitor is connected in a series with a 20 microfarad capacitor across a 24 volt supply. Calculate the total charge on the capacitor. Now, we were looking at this. The first thing we have to do is to find the equivalent capacitance of these capacitors. Thus, we can now find the quantity of charge or the total charge on the capacitors. So when we look at the question, we can see that the capacitors were connected in series. So let's find our equivalent capacitance. So to find our equivalent capacitance, we use the formula 1 over equivalent capacitance equals to 1 over C1 plus 1 over C2. So from our question, we're given the first capacitor to be 10 and the second capacitor to be 20. So we have 1 over equivalent capacitance equals to 1 over 10 plus 1 over 20, which is equals to 2 plus 1 all divided by 20, using 20 as our lowest common multiple in this fraction. So we have 3 over 10. Then 3 over 10 is not the final answer. So when we cross multiply, so our equivalent capacitance will then be 20 divided by 3 microfarad. So which is approximately 6.67 microfarad as our total or equivalent capacitance. Now, the next thing for us to do is to find our total charge or the quantity of charge on the capacitance or the capacitors. So to find the quantity of charge, then we use the formula, the equivalent capacitance times the voltage. That will give us the quantity of charge. So we have 6.67 times 10 raised to the power minus 6 times 24. We're given 24 as our voltage. So we have 6.67 times 10 raised to the power minus 6 times 24. So then when we multiply this together, we have 160 times 10 raised to the power minus 6 coulombs, which we can further rewrite as 160 microcoulombs as our final answer. The next question we have here is from the WAEC past question 2008. It says a 7 microfarad capacitor is discharged through a resistor of 15 kilo ohms. If the initial voltage across the capacitor is 20 volts, find the voltage across the capacitor after 2 seconds, assuming the discharge follows an exponential decay. So you must understand that the voltage across a discharging capacitor is given by the formula V into bracket T, which is the time, close bracket, equals to V node times E raised to power minus T divided by RC. Now, from our question, we're given our V node, original voltage, to be 20 volts. We're given our resistance to be 5 kilo ohms, which we can convert to 5 times 10 to the power 3, which is 5,000 ohms. Then we're given a capacitor of 7 microfarad, which we can convert to 7 times 10 to the power minus 6 farads, and we're given a time of 2 seconds. You must understand that RC there is the resistance and the capacitance. So we can say that RC, what's the value for our resistance? We have 5,000, or resistor 5,000 times 7 times 10 to the power minus 6, which is the value for our capacitance. When we multiply this together, we'll be having 0.035 seconds. Then we can now plug this into our formula, which is Vt, or V into bracket T, equals to V node times E raised to the power minus T all over RC. So that will be V into bracket 2 equals to 20 times E raised to the power 20 times E raised to the power minus 2 all divided by 0.035 seconds. And when we multiply this together, we'll be having approximately this to be 20 times E raised to the power minus 57.14 as our final answer. So the last question we'll be looking into for today's class is from the WAEC past question 2009. It says a capacitor with capacitance of 12 microfarad is connected to a 6-volt battery. Calculate the amount of energy stored in the capacitor. We know from our understanding of capacitor that the energy stored in a capacitor is E equals to half CV squared, where C is the capacitor and V is the voltage, or C is the equivalent capacitance, as we may have it in some questions. So from our question, we're given a capacitor of, or capacitance of 12 microfarad, and we're given voltage of 6 volts. So we can convert our capacitor to be 12 times 10 to the power minus 6 farads. So then we can plug this into our equation, which is half times 12 times 10 raised to the power minus 6 times 6 squared. So we have half times 12 times 10 raised to the power minus 6 times 36. And when we multiply and divide through by 2 together, we'll be having 216 times 10 raised to the power minus 6 joules, which we can further write as 216 microjoule as our final answer.